26. Number 131. What 3D objects would be used to model this doghouse? Now, you should recognize this doghouse from a previous problem that we've done when we tried to figure out the height and the volume, but now they're just asking out what shapes make this doghouse. The bottom is pretty simple, looks like a box. So the bottom portion is going to be a rectangular prism. The top portion, however, is not a pyramid. The top has a triangle in the front and a triangle in the back. So that triangle is our base, and it's going to be called a triangular prism because notice all of the sides, the faces that make up this top shape are rectangles. So the side there will be a rectangle, the left side's a rectangle, the bottom, if you took the roof off, would be a rectangle. So this is going to be a triangular prism because triangles are the bases and rectangles are all the faces. Okay, let's keep moving. 132. Identify the 3D solid that will be formed by the net shown. So a net is when you take a three-dimensional object and you lay it out and take a look at each of the faces and the bases. Now, we notice that there is 1, 2, 3, 4 triangles here. Triangles are the dominant shape. So that means this is going to be a pyramid. Now, choice D is not a pyramid, so I can cross that off. What I'm looking for is the last side to see what type of pyramid will be formed. The last side here will be your base. It looks like a square or a rectangle. So looking at our choices, we can also cross off A because A says a prism. So our choices are going to be either a triangular pyramid or a square pyramid. It's going to be choice C, a square pyramid, because your base here is a square. And you always name a prism or a pyramid after the shape of the base. Let's keep going. 133. Which of the following nets would use the standard volume formula V equals big BH? Okay, so we have 3 categories of volume formulas. One's for things without a point, a volume formula that has a 1/3 in front of it for things that do have a big point and apex at the top, and then the volume formula for a sphere. Now this is going to be for anything that doesn't have a big apex at the top. So for prisms and for cylinders. So if it has a big point at the top, like a pyramid or a cone, that's going to use a 1/3 big BH. So let's go through our choices and see which of these shapes will be either a prism or a cylinder. All right, now the first one, most of the faces here are rectangles. 1, 2, 3 rectangles. And then I have 2 triangles, top and bottom. This is going to be a triangular prism. A triangular prism. Because there are more rectangles than there are triangles. So the answer for this, rather the volume formula for this one would be your standard V equals big BH. So I do like choice 1. Now the next one, well, I have mostly triangles. 1, 2, 3, 4. So this is going to be a pyramid. And my base is going to be this shape, which kind of looks like a square. So choice 2 is going to be a square pyramid. Oh, that's not how you spell square. Fix that. Square pyramid. So not choice 2, because that would use 1/3. Now the next one is going to be a cone. See, we have only 1 circle. So a cone has 1 circular base. So a cone is choice 3. And no, a cone uses 1/3 big BH because it has a big point at the top. And lastly, we have 2 circles. Those 2 circles are going to be our bases. And this rectangular portion is going to wrap around and form the curve of my cylinder. So this is going to be a cylinder's net. And yes, for a cylinder, because it doesn't have a big point at the top, it will use the standard formula for volume, V equals big BH. So I also like choice 4. Let's go through the different choices and see which one we want. A uses 2, which is not correct. B says 2 and 3. 2 and 3 should use the 1/3 big BH. So definitely not choice B. Choice C says 1 and 4. I think that's the one. And choice D says only 4. But choice 1 also uses big BH, so it's not choice D. So choice C, prisms and cylinders. Let's keep going. 134. The two isosceles trapezoids below are similar. Okay, so two really important things right out of the gate. Isosceles trapezoids. Isosceles trapezoids have the two legs that are not parallel congruent. So for the smaller trapezoid here, the 3 on the left for the left leg will be congruent to the 3 that's missing there on the right. For my larger trapezoid, again, the two legs, I'm going to give them 2 tick marks each, are both going to be 5 since one of them is 5. So that's important information with the isosceles piece. The other thing that's important here is they said it was similar. If two shapes are similar, I'm thinking proportions, I'm thinking scale factor. So really great information there just from that first sentence. Find the exact value of the perimeter in terms of W and V for the larger trapezoid. So what I want to get is the perimeter for my larger trapezoid. I have 4 sides for a trapezoid. So 1, 2, 3, 4. I like to get it set up. They want my answer to be in terms of W and V. So that means that some of these lengths I'm not going to be able to solve for. My answer should have a W and a V in that perimeter answer. Now, I'm going to take a look at this and I'm going to think about, well, what side lengths do I have and what am I missing in order to get the perimeter? Right now, I have the 5 for the left and the 5 for the right, and then I have V for the bottom side length. And they said that I can put my answer in terms of W and V, so I do have 3 of the 4 side lengths that I need. In fact, I'm going to start filling it in. I have 5, 5, and V. My last side length is missing. So my last side length is here, and I don't have it. I'm going to need to solve for it. Now, if I take a look at what it matches up with, it's the top shorter parallel side. It matches up with this W. So this W is going to turn into this missing side length, as long as I multiply it by the scale factor. Now, I like to go ahead and keep things safe. And instead of trying to figure out scale factor right away, I'm just going to do some proportions. I'm going to match things up and set up a proportion. So W is going to match up with whatever side length it is here. And I'm going to call it a question mark. I don't want to throw in another variable. That's just going to get me all mixed up. So I'm going to say W matches up with question mark. And then something else that matches. I have this 3 on the left, and that matches up with my 5 on the left. Same way that this 3 on the right will match up with the 5 on the right. Okay, so 3 and 5 is going to be my other ratio that I'm going to match the W and the question mark up with. So W over question mark is the same as 3 over 5. Now remember, I want to solve for this question mark. I just didn't want to give it another variable. So I'm going to go ahead and cross multiply. So W times 5 is 5W, and then 3 times your question mark. So 3 question mark. I want to get the question mark, so I'm going to divide both sides by 3. So 5W over 3 equals my question mark. Now that's exact. If I did 5 divided by 3, anything divided by 3, if it's not a whole number, it's going to be a repeating decimal. So what I want to do is I want to keep it just like this. My last side length is 5 over 3W, or 5/3 W. Okay, that seems to be my last side length. They said I can keep it in terms of W and V. So for my last side, I'm going to say that it's 5/3 W. If I want to simplify my answer just one more step, I can combine the two 5s because they're whole numbers. So my final answer for the perimeter is going to be 10, the 5 and 5 together, plus V plus 5 2/3 W. And that answer is completely correct. It's exact, and it's in terms of W and V, meaning I use W and V in my answer. So the key for this problem, you may not be able to solve for a side length. You may have to express it as an X value or Y value, a variable. You may have to leave it just like that. So if your answer, or rather your question, says leave it in terms of X or leave it in terms of W, then just leave it with the variable. But still, set up proportions if you know they're similar. Match things up, set up your proportion. Okay, let's keep moving. Last question on the page, number 135. The square pyramid and cone have the same volume. Find the radius of the cone. Okay, so the ask here is to find the radius. This is a question that I'm going to have to work backwards in order to get the radius, because they're talking to me about volume. They're saying the volumes are the same, and then they're asking me to work backwards and get the radius, which is something I would usually have in order to get volume. So we're going to be working backwards. Now, to work backwards, you first have to know, well, I'm looking for the radius of this cone. Do I have the volume? Do I have area? Do I have anything? Like, what do I have about this cone? And right now, I don't have volume. But because they told me that it's the same as the pyramid, maybe the pyramid can tell me the volume. So looking at the pyramid, I do have enough information to figure out the volume. Let's think about what the formula is for volume of a pyramid. Volume of anything with a point at the top is 1/3 big BH. The height, they told us, it's 11.2. So I'm going to plug in 11.2 for the height. I'm going to bring down everything else. Now, big B is always the area formula for your base. Now, they said that this base was a square. So that means that my base that has a length of 6 centimeters is also going to have a width of 6 centimeters. All the dimensions there are going to be 6 for my base. I'm going to replace big B with the area formula for a square. So I'm going to replace this with length times width. Let's keep going. Volume equals 1/3. Now I have 6 times 6 as the length and width of my base. And my height is 11.2. Okay, I'm ready to figure out the volume. So let me go ahead and plug this into my calculator. I'm going to do 6 times 6. It's going to get me 36 times 11.2 equals, and now divide it by 3 equals. So my volume for the pyramid is 134.4 centimeters cubed. So I'm going to write that down. The volume here is 134.4 centimeters cubed. And if the volume of both the pyramid and the cone are the same, that means the volume for the cone is also 134.4 centimeters cubed. Now I have the volume and I have a height, so maybe I have enough information to go ahead and get that radius. Let's write down the volume formula for a cone and see if that's enough info. So let's see. Volume of a cone is again going to use 1/3 because there's a big point at the top, big BH. And now I have big B as a circle. So instead of putting big B, I'm going to put the area formula for a circle. Pi r squared h. And now let's see. Do I have enough information to start solving for the radius? Well, I have the volume. It's the 134.4. And I have the height. It's the 11.2, which leaves the only variable to be r. I'm ready to start plugging in and solving for r. I do have enough information. Okay, so let's plug in. The volume is 134.4 equals 1/3 pi r squared, and then my height is 11.2. Okay, let's start solving. Let's give myself a little bit more room to write here. Okay. So, one thing that I want to get rid of right away is I want to get rid of that 11.2. Now, since 11.2 is being multiplied to the rest of the formula, I can divide both sides by 11.2 to get rid of that 11.2. So in my calculator, 134.4 divided by 11.2 is 12. Okay, so now I have 12 equals 1/3 pi r squared. Okay, something else that I don't really like is that 1/3. Now, to get rid of the 1/3, I can multiply both sides by 3, and that's going to get rid of the denominator of 3 and get rid of the 1/3. So now let me multiply both sides by 3. And now the 1/3 and the 3 cancel. On the left, 3 times 12 is 36. And that leaves me with pi r squared. Okay, I'm getting much closer to getting the radius by itself. Now, I want to get r squared by itself. So I'm going to get rid of that pi. I'm going to divide out the pi on both sides. So now I'm left with 36 over pi is equal to r squared. Almost have r by itself. Now I want to get rid of that squared because I just want the radius, not the radius squared. So to get rid of the square, I'm going to square root both sides. The square and the square root cancel. So that means that r is the square root of 36 over pi. They didn't tell me how to round. So I'm going to look at my calculator to see, is this a perfect number? But if it's not, then I'm just going to leave it right like that. So in my calculator, 36 divided by pi equals, so it's about 11.46, and now I'm going to square root it. 3.385. Okay, that's definitely not a whole number or an easy number to write down. So if I want to keep this exact, because they did not tell me to round, I'm going to keep it just like that. Square root of 36 divided by pi. If they did want me to round, this is approximately equal to, if I round to the nearest tenth, 3.4, and my units are centimeters. So either one of these answers. I'm going to go to the top. I'm going to write down both. Okay, so I have the square root of 36 over pi, which is approximately equal to 3.4 centimeters. So the first one is exact, and the second one is rounded to the nearest tenth. Okay, so we're done with this question. We're done with this page. And the key takeaways here is if they're asking you for a particular length, and they're talking to you about volume or surface area, you're probably going to have to work backwards. The issue with this question is it wasn't as a straightforward working backwards problem as we may be used to. In this case, we had to first find the volume of a shape that has the same volume, which was the pyramid. And once we had that volume, then we could work backwards for our cone. So this required one additional step in working backwards. Okay, let's keep moving.